Hey, welcome to the slideshow where you get to hear your teacher say "damn," and he actually meant to say it. We are talking about hydroelectric dams and how they produce power. And so when you look at this picture of a hydroelectric dam, you get a clear sense of how it is able to build up potential energy. So look at the water level on the left and compare that to the water level on the right. And you notice on the right, you don't even really see the water. It is so far down below, it's not even really in the picture. So that is the way that it's building up gravitational potential energy. The water is so much higher on the left than it is on the right that that leads to gravitational potential energy. So when you convert it, it's converting it by falling through the dam. And in this picture, you can see that the water on the right side is falling through the dam, spinning a turbine, which would happen down in this region here. And that's going to turn a shaft, which then spins a magnet and a coil of wires, and that produces the electricity, which then goes into the grid. And this is how simple hydroelectric power actually is. It is converting that potential energy into kinetic energy as it falls through the dam. When you look at Connecticut, we actually do have hydroelectric power plants in different places around Connecticut. And the red spots on this map show places that either have hydroelectric dams or could have them. But notice the middle of the state. What stands out about the middle of the state is we have rivers, but yet there are not red dots. And so that means no hydroelectric power. And we start to think, well, why is that? And the main thing that comes down to is the geography of the land. If a hydroelectric dam is going to be effective, it must be capable of building up sufficient elevation of the water behind the dam so that it can fall through it. If you cannot build up much gravitational potential energy, then you can't actually get that much power out of it. So it's not the flow of the water, but rather the height that you can build the water to that makes a difference in terms of how much power is able to be produced. Now consider the Connecticut River. The Connecticut River is long and relatively flat. And as a result, if you tried putting a dam across it, the water would rise up a little bit, and then it would go around your dam. And then you wouldn't have much hydroelectric power. So places that can do it must have restrictive walls. They must be in a valley to allow the water to be able to build up and not flow around the dam in the process. And as a result, they can build up a good amount of gravitational potential energy. When you look at positives, there are definite advantages to hydroelectric power. You're going to not get emissions to the atmosphere during the process of producing electricity, so there's no gases given off to the environment. One advantage it has over other renewables is you can use it at any time of day, unlike solar. As long as you got sufficient flow of that river, you'll be able to produce power. Another real advantage over other renewables like solar and wind is you can store the energy and use it when you need it. So during times of peak power demand, then you open up the gates and allow the water to flow through. But if in fact the demand for electrical power is not very great, then you can close those gates and build up the water and build up gravitational potential energy until you actually need the electricity. That's a real advantage that hydro has over other types of renewable energies. Like other renewable energy sources, once you build the dam, it is free energy and it is renewable by nature. But we do have some problems. One of those problems would be that hydropower can inhibit the certain species of fish that will swim upstream in order to lay their eggs. And when you look at what can happen, a fish that's swimming upstream runs into the dam, they are stuck. They can't get around it, and as a result are unable to lay their eggs and therefore unable to reproduce. So some fish populations have been severely hurt by this. One strategy around that is to build something known as a fish ladder, which is an alternative route where fish can go around a dam and continue to travel upstream, and that enables them to live the way that they are accustomed to living with still getting hydroelectric power. Another issue would be, well, when you build the dam, you have to be prepared for areas around it to go underwater. When you look at the initial expense, it's rather significant initial investment, so it's definitely not cheap at first. And when you look at the issue we talked about before, you have to be able to build up that significant change in elevation in order to make it a worthwhile gain of power. And then the final thing to consider is the sediment flow. Think about what's happening with a river is it's carrying sediment as the water is traveling. And when it runs into the dam, the speed is significantly reduced. Well, if the speed slows down, the sediments will drop, and so they get deposited on one side of the dam. The water that flows through the dam generally lacks sediment, and so what happens is downstream you don't get as much sediment being transported. So here is an aerial photograph looking at coastal Louisiana, and the bottom photograph, as it says, is April 9th, 1976. The upper paragraph picture is going to be November 18th, 1999. So some time has passed, and when you compare those two, you'll notice that there are sections that were fully filled in with land that in the newer picture are underwater. And what we're seeing is sinking of wetlands, that wetlands are going through some serious subsidence, and so they're kind of sinking underwater and eroding because they're not being replenished by new sediment coming down the river. With all of the flood controls and hydroelectric dams that have been placed on the Mississippi and its tributaries, there is not as much sediment that's coming down the river, and the net result is loss of wetlands on the coast of Louisiana. So you might be saying, well, why does that matter? It's just a loss of some swampy area. But those wetlands play an important role in protecting the land from storm surges from hurricanes. They are also valuable places for different species of fish to reproduce. And when you look at the loss of land that's happening, it's happening at a pretty alarming rate in coastal Louisiana. So this is definitely an issue that we should be concerned about. And that does it for our discussion of hydropower.